A fairly common question on the AP exam is a question that has to do with finding averages. And the reason that that's a challenging question sometimes is that, I mean, if you remember from the lesson that we did before this one, there are sort of two different averages that you might be looking at. The two things that we've talked about. One, we've discussed the idea of the average value of a function on an interval. Right, the average value of a function is something that was covered back in chapter 4. The average value of a function on an interval is 1 over b minus a times the integral from a to b of f of x dx. So if you want to find the average value of the function, this is the equation that you use. The other average that we've discussed, and this came up in chapter 3, is the average rate of change. The average rate of change of a function on an interval. So the average rate of change, this is the one that's f of b minus f of a over b minus a. Right, and so when you got one of these AP problems that's about averages, you're going to need to figure out whether you need to use the average value one and do this process, or if you're looking for the average rate of change and doing this one. And the point that I need to get across, and this is a really, really important point, a lot of people think, oh, well, if it says average value, then use this one. And if it says average rate of change, then use this one. And it's more complicated than that. And the thing you really, really have to pay attention to is that this thing says the average value of f of x. And this one says the average rate of change of f of x. And something I hope you've gotten used to is a lot of times they'll ask you, oh, find the average rate of change of f of x, but then they'll give you a picture of the derivative. Or I mean, they'll sort of mix the things up. And so the point I have to get across to you is you absolutely have to pay attention to every word in the question. Look not only at the word average, also look at what they're asking you to find the average of, because it makes a difference. So I've got there's a second video that's got a bunch of examples of this. In the two examples I have here, it's just going to sort of be us talking about the different ways these things can be interpreted. So let's look at the first type of those. Alright, so my first example here is how can you find the average velocity of an object? Like, in what way could that be done? And what I want to discuss is I sort of want to discuss there are two ways this could be done. One way to find the average velocity would be to find the average value of what? Well, if you wanted the average of velocity, you'd be looking for the average value of a velocity function. Right? It would mean that you would do 1 over b minus a times the integral from a to b of the velocity function. Now, while I'm here, I might mention, like, what are the different ways that the velocity function could be given? How could this happen? One, they could give you a velocity function. They could say, v of t is t squared. And in that case, we can integrate, either by hand or using a calculator. Another option is they could give us a graph of the velocity function, in which case we could, I'm going to call it count boxes. Technically, they could even give us a table of values of the velocity function. And in that case, we could use one of the Riemann sums. Either a left sum or a right sum or a midpoint rule, something like that. But the point I'm getting at, the actual meaning of this lesson, if they want average velocity, one option is to find the value of the velocity function. Right? So that works well if you have a velocity function. But is it possible that they could give us something different? I would say yes. One other way to find the average velocity of an object is you could also find the average rate of change of the position function. And that may sound a little bit crazy, but think about it for a minute. Think about what velocity is. Velocity, like by definition, velocity is the rate of change of position. So if someone were to ask you for the average velocity, you could just as easily find them the average rate of change of the position function. And so how would you do that? Well, the rate of change of position would be, P of B minus P of A over B minus A. And so it's sort of like, well, there are two ways to do this problem. You could either do it this way, or you could do it this way. And a lot of people ask, well, which one do I pick? Here's the reality. You're not going to get to pick. If the problem gives you velocity, then do it this way. If the problem gives you position, then you have no choice. You have to do it this way. So the thing you need to understand is that when a problem is asking for an average, there may be two ways to think about it, and you need to do it in the way that the problem is set up for. I've got one more sort of talking example, and then like I said, the second video that I have is I think it's 4 just straight examples of how you do this stuff. So my next example, how could you find the average rate of change of the depth of water in a tank? And so it's sort of like, well, there are two ways to do this. One of them is, if they want the average rate of change of the depth of water, one way to do it would be to take the average value of a rate function, right? So if they give you a rate function, if they give you a function that says, r of t is the rate of water entering the tank, in other words, if they already gave you a rate function, then cool, we could find the average value of that rate function by doing 1 over b minus a times the integral from a to b of the rate function, right? And I don't know if you guys can see this, you haven't seen many of these problems yet, but think for a minute, how else could this problem be done? What other information might be given? How else could we interpret this? The idea is we might also be able to do the average, not value, the average rate of change of like a depth function. So depending on whether they give you a rate function, like I talked about over here, or if they give you a depth function, we'll handle it in different ways, right? If they give you a depth function, then great. Take the rate of change of that depth function. Do d of b minus d of a over b minus a. So I suspect that this is a little bit confusing now. I think that the next video that has some examples in it will help tie up some of these loose ends. But the point that I'm getting at is that you can't, I think that the summary of the whole lesson is you can't just look at a problem and say, oh, it says average rate of change, that's going to be this one. Or it says, oh, it said average value, so that's going to be this one. You really have to think critically about the problems and look not just at what it's like the average word after that, but what do they want the rate of change of? What do they want the value of? So check out those examples and hopefully they'll make sense.